Hi, I'm Kevin Drinkall.
Hi, and I'm Michel Nicolai, and we welcome you to Zyxel Networks podcast.
We've been in the network industry for over 15 years, and in these podcasts we want to try and untangle the world of networking, debunk some of those myths, explain some real-world examples along the way, to help you make better choices about selecting the right tech, product, and even help you guys build faster, more reliable, scalable networks, or just to keep your kids happy at home. Welcome back to another podcast.
Yeah, and in today's podcast we talk about a PoE standard, the Power over Ethernet standard that we provide on our network switches.
So often PoE is associated with switching, but obviously it's also the powered device side as well, right? So it's the type of applications, and we're going to cover a little bit about that in this podcast. But Power over Ethernet, or PoE as it's commonly known, is really designed to utilize a single cable solution to power the device and carry the network traffic at the same time. So it's often referred to as Ethernet, and the cabling is often referred to as a category 5, 6, 7, and then there are others as well. And the idea is to make the installation a lot easier. And, there's no need to run local power or use some kind of electrician to do installation of devices that can utilize this kind of power output.
Yeah, and I think another benefit also is then when you consolidate all the power through the network, you probably can also have some redundancy in your network, because the power is not taken locally from the power grid, but everything is consolidated from the switch. So even when you run a UPS, a battery in your network that can power the switch in case of power failure, then still you can remain using your network and all the devices that are connected to this network.
So additionally, these types of power supplies, or power over Ethernet, you can also utilize them in conjunction with multi-gig. So that's 1 gig, 2.5 gig, 5 gig, and even 10 gig. Though I haven't seen any 10 gig devices yet, but I'm sure they'll appear, right? And the benefits really is that in conjunction with that, you can also add some kind of application or management structure into it, like scheduling, and we'll cover some of that as we go through this episode as well. Also, if you're really interested in multi-gig, we do have another episode podcast which covers multi-gig in a bit more detail as well.
But we know there are some limitations, of course, because the Ethernet standard, as we know today, it is limited to 100 meters. So that's also valid for the PoE, the Power over Ethernet that we are providing over the cable. So there is a limitation on that part.
Yeah, I mean, there are some exceptions to the rule, and we'll cover some of those. There are some specialist type of deployments around CCTV camera deployments, and this is something that we'll cover as we go through this as well. So there are quite a lot of common applications for PoE. So often you'll see this with desk phones, wireless access points, even CCTV like we just mentioned now, right? And like I say, there is some more advanced features around that as well. But access points themselves, they also can carry multi-gig. So often you'll see the multi-gig in conjunction with PoE powering that device, and makes the whole process much easier to deploy.
Yeah, but we also see Power over Ethernet configurations with other kinds of devices. Yeah, like Kevin mentioned, the desk phones, the wireless and CCTV cameras are the most common one. But what do you think about IPTV decoders, audio decoders, or POS systems, or even IoT devices, that people nowadays not only have in an office environment like door access controls or those kinds of applications, but also when you're using it at home in a home environment.
Absolutely, I think there's a wide range of where it could be used, right? So I've seen it in used by POS systems, and even speakers, ceiling speakers. I've seen a lot of these applications where they're powering from PoE, and actually in recent times I've actually even seen LED powered strips being used in smart buildings. So when we start to look at smart building and about energy efficiency, PoE can really be part of that whole ecosystem, especially when you're wanting to manage the data element as well, right? So like Michelle said, you've got door access, even some kind of industrial application control systems use PoE as well, right? So the scope is very, very big. And there are even custom kind of solutions as well that we see out there. So let's talk about where PoE comes from and how it's standardized. So when we talk about PoE devices, we're talking about devices that are powered as well as the provider of that PoE as well. So we have the switch side and we have the device side as well. And they need some kind of compliance in order to be able to talk to them across different vendors. So there is a standard called 802.3, which is part of the IEEE standard. And this breaks down into different voltages. So 15.4 watts, 30 watts, 60 watts. And there is also something which I think we should mention is the passive PoE, because this is not part of the standard and is a different method of powering devices. So passive PoE is actually a way that we just pass devices the voltage directly over the cable, has no intelligence, and is different from what we call active PoE, which is part of this standard. And active PoE is really designed to optimize for safety. So when you just push power through a cable, there's no way to protect that device from being damaged. And part of the IEEE standard is to ensure that the device is protected. So within the standard, actually over time, it's been introduced and has been increased, right? So there are three main standards that are used in today, and they are 802.3 AF, which provides up to 15.4 watts of power per port on a PoE switch. There's 802.3 AT, which provides up to 30 watts of power per port. And the latest standard, which is 802.3 BT, provides up to 60 watts per power. Now, there is actually part of the BT standard actually goes past 60 watts, but it's a little bit more specialized and really aimed at the CCTV industry. I think that's predominantly where you'd see that, and that goes up to 100 watt or 99 watts.
I think, yeah, there's a good clarity on the IEEE standard with the three different standards that we have. But what's really important, and I probably will address that later on, is to remember all the standards to which classification they belong. To give you an example, the AF standard, with the 15 watts of power budget per port, they're also known as the classification 0, 1, 2, or 3, depends on the wattage, of course, but that is very important later on when we do the calculation. So if you need more power and the classification number 3, so 15.4 watt is not enough, we need to scale up to the AT standard with the 30 watts power per port. And that's also known as device classification 4. So that's really good to remember, because those kinds of data are always provided on the datasheet of your vendor of the device that needs to be powered. So 30 watts is not the maximum. As Kevin mentioned, we have the BT standard as well, where typically it's up to 60 watts. That can be classification number 5 or 6. And if it's more than 60 watts, then classification 7 or 8 are in there. But it's very good to know, to remember the classification, because this will help you on your calculation depending on the power budget that you might need when you want to power your devices.
I mean, at this sort of high PoE budget, right, with more over 60 watt, I'd be worried about the cables anyway, right? Another thing or factor to really understand is the difference between what they classify as PSE and PD. So PSE is when you often see it in the data sheets and the information about PoE, you'll see power sourcing equipment is PSE. In other words, in our case or our example will be the switch. And you have the PD, which is the powered device. So the physical device that's being powered from the switch, in our example. So in our example, it could be an access point or a desktop phone, like we mentioned before, or any of those other devices that we kind of use as examples. And then you have something powering it, which is the powered device. The reason why we say this is because it's pretty important when you are trying to do calculations, especially around the classification and consumption mode.
Yeah, because that's one of the features that is quite unique to the Zyxel product, that you can choose how you want to configure your switch. By default, for instance, our switch is operating in consumption mode. So that means that he will provide the power as is needed by the device at that time in that state. But it's also possible to configure and set your switch into classification mode. And that means that we reserve the power that is classified for the PD device. So as I mentioned before, if you check on the data sheet of your third-party device that needs to be powered, you check on the PD, and there you probably see that the classification is for that product, for instance, 3. And if you know that it is a classification 3, then you know that this product will not consume more than 15.4 watts. Of course, it can mean that on average, that in normal state, it will take less, but it will reserve and protect the power on the switch to make sure if more power is needed, that your switch can provide this wattage, this additional power. So maybe we should do a small example to clarify more the advantages of the classification consumption mode.
Absolutely. One more point though, before I move on to an example, is that the reason why we mention PSE, which is the power source and equipment, versus the power device, is the standard is that the PSE, the powered source equipment, i.e. the switch, 15.4 watts is guaranteed at the port. But actually, over the length of a cable, actually the guarantee of the power at the device is actually much lower. So when you're looking at this, if something actually says it uses 15.4 watts or it uses 15 watts, actually the chances of using that product means you probably need to push into the next classification above it, because you can't guarantee that at the end of the cable. Now there's a full table with all information about details about how PoE operates and what it supplies at the PSE and what it delivers at PD as well. And this is a compliance thing, so it doesn't mean that it's unique to Zeisel. It is a standard. So just bear that in mind when you are looking at the power consumption. So as an example, I would say like an IP phone, a desktop phone that you use in your everyday office. Often they're classified as a class 3 product, so that means technically they go 15.4 watts. So if you're using this in classification mode, it would automatically allocate 15.4 watts from that budget. But if the spec sheet shows that its device is drawing 9 watts as an average draw, the consumption mode will actually allocate 9 watts rather than the full classification of it, so 15.4 watts. So instead of using 15.4 watts out of a budget, it would be using 9 watts, okay? So if you had a switch that had a total PoE budget of 60 watts, and you used, in this same scenario, you would be able to power 4 IP phones connected in classification mode versus 6 in consumption mode, because you will be able to reuse the PoE budget. If you start to scale that up in larger scenarios, technically you can double the amount of power devices on a single switch versus, in fact, even saving a switch. You could use one switch rather than 2 switches. Of course, some things you should also consider is if the devices that you are connecting fluctuate. For example, outdoor access points, they might often have a heater which can use sometimes in some products 10 to 15 watts more than when it's using it in standalone mode, right? And also some devices like phones typically use 1 to 2 watts more than when they're in idle to when they're in use. So if it's a mission critical device, you should maybe consider using it in classification and or setting priorities. So even in consumption mode, you can set some kind of priorities, which we'll touch on a little bit later.
Yeah, but I have to say something about power budget, because there's a lot of confusion on power budget. Because if you look at the Zeisel datasheet, the power budget is really stated as the number that you really can use for all your devices to be powered. But a lot of manufacturers are providing the wattage, the power consumption, not only the budget that you can use, but also including the wattage that the switch is using to operate. So, for example, if the data sheet says 150 watts, check if that is the real value that you can use on the port to power your devices, or it's also included the power consumption that the switch needs to operate. Always check that.
So I guess we should talk a little bit about our products and how they're kind of named so that you can understand the PoE or which versions of our switches actually have PoE. So within our range, we have a naming convention. So we have at the beginning of the leading of each switch, we have the series and the type. So like XGS means it's a 10 gig switch uplink with 1 gig ports. GS is a completely 1 gig switch. And then we have other switches like XMG, which is a multi-gig switch. And at the end of those switches, we often have the denominator for PoE. And this is broken down into high power, which is HP, FP, which is full power, and EP, which is eco power. And the difference between those really is that HP is a standard budget, FP is a higher budget, and EP is a lower budget in the whole scenario or the whole series.
Yeah, and what is really good about the Zyxel portfolio is that Zyxel is offering a broad range of switches from very low power budget to very high power budget. And the reason for this is that the cost of making a PoE switch is much related to the power supply that's in there. So if you are looking for a good switch, you start off with the calculation, as we mentioned before, to see the wattage, the power you needed, and then you can select based on your power what kind of switch will fit best in your budget. So you can go and select a GS 1915 with 8 ports. It's an EP switch, it's 60 watts. Really good for small office where you only want to power maybe 1-2 devices. But maybe you have a larger installation and then 60 watts is not sufficient. You have much more devices you want to run, or maybe you want to run devices that require the high PoE BT standard up to 60 watts. So then you need a higher capacity switch as well. But we can even deliver a very big switch with a big power supply up to 960 watts. And nowadays that is really important, because many of our customers have less and less rack space available and want to put as much as a number of ports. So the port density is important, but also the power budget that we can offer in a 1U space becomes more and more important.
So consumption mode really becomes quite important in that process as well, right? Because not only are you're giving the high PoE budget, but you're also allowing a very flexible approach to deliver power to devices, right? Like we said, in some scenarios, double the amount of devices on one switch. So for consumption, the actual switch itself is using power. So, to reduce the power overhead, you're using one switch. You're being much more efficient with what the switch can actually deliver. And also very flexible approach to the applications that you can use as well, right?
Yeah, and I think we should highlight a very specific application in this case. We said that IP phones and wireless access points are one of the most common one. But I don't know if people know, but within the Zyxel portfolio, we have a special CCTV switch, the GS 1350 series. And that type of series has very nice features that can make your life easier when you do a PoE deployment with CCTV.
So, in this switch actually has some very unique features. And I think, so, like we said before, we mentioned about limitation on the distance. And actually the 1350 has ability to extend the range of PoE to 250 meters. And also contains a function for continuous PoE. So one of the problems with PoE cameras or IPTV cameras is actually if you reboot a switch for any reason, whether it's a firmware upgrade, etc., then you often have the reboot time of a camera as well. And some of those cameras can take a considerable amount of time as they do their self-checking, etc. So if you are doing maintenance on a switch, i.e. firmware upgrade, or you're rebooting it for any reason, then the switch will actually keep the power to the ports while it's rebooting. So this means you don't have to wait for the PoE to reboot the camera. It's already powered, and then the switch will come back on, and then start switching again. The other feature, actually, which we have introduced in some other products, but it predominantly came from this switch, is auto PD recovery. So like we mentioned before, PD means power device. And what we can actually do is detect whether the device fails or becomes unresponsive. There's a number of different ways to do that, but you can make a bunch of settings on the port to check, whether you just ping the device or whether you just use some kind of protocol to check the neighborhood. And then if the device stops responding, the switch will go through a reboot cycle by itself. So, for example, in a camera, if the camera stops responding for any given reason, it will be able to reboot the device by itself and then go through a series of checks. You can even specify how long the camera takes to reboot so that it doesn't try and reboot over and over again. So adding some real intelligence into that process.
Yeah, so this is a very specific switch series that we have with those special features on, but we have a lot of more features that's related to the PoE in our Nebula ecosystem. So if you're running your switch in the Nebula cloud solution like we have today, we have some nice features there that can help you in a lot of different ways. For instance, we offer PoE scheduling. So that means that for a period of time, we can switch off or turn on devices, for instance, in schools, when the students leave, maybe at the end of the afternoon, and then only the teachers are remaining at school, then it's not necessary to keep all the access points alive in the school, only a few where the teachers are located, and then we can switch those out and we can save power, for instance, on this, especially in these economic environment where we're in at the moment, where energy is quite expensive. It could be, a good money saver.
I mean, we've even seen projects, in hotels where they actually power down devices during the evening and even, reboot the product in the morning. So, for example, we had one project where the building was completely off grid and we needed to really keep the power consumption of the whole building quite low. And during the evening, they would actually turn specific access points off and allow the other access points to do the coverage. So they actually had lots of APs because of the density of devices. But during the evening, and when I say off-peak times, I think it was around 2 a.m. till 4 a.m. or something like that, or 5 a.m. They would turn the devices off and then turn them back on again on a schedule. And I've seen it in offices as well, right, where they turn the phones off during the night and turn them back on again instead of just leaving them on all night.
And I think it can also be helpful for security reasons, because as you mentioned, when you turn off your access point during the evening, then nobody can access it because it's really offline. So that's something how you can use the scheduling as well.
Although, rebooting things is not really, it's not an IT's manager's nightmare, really, right?
But if you look to a security guy, he would love it.
So there's pros and cons depending on who you are.
Yeah. No, and another thing that we offer in Nebula is that we do the PoE monitoring, that we can see the usage per switch and even per port. So we can see if, let's say, the device is taking more power over time. We know that when products are being powered for a long time, will get older and need some more power. And probably they get more heat, so they consume more power. So if it's too much, you can really see this happening within the Nebula system.
I think one of the really nice features as well within Nebula is we have these advanced PoE controls as well, right? So where we've really taken care of all the kind of, or tried to make accountable for all the scenarios, right? So we have a power mode which helps protect devices from being damaged, even against non-compliant devices, right? So some devices they don't seem to apply to IEEE standards, or they don't really draw the correct amount of power, etc. And we also have a method in which we'll boot gradually and add voltage to it to allow the device to boot. When the device responds, then it stops increasing the power. So, and over time, we've actually come across lots of different devices like this. And so our history in switching and PoE has actually helped us advance and create features like this. Of course, we also have these features like priority, which allow us to define which devices are mission critical. So in a worst case scenario, if the device or the switch does exceed its power limitation, then it will actually prioritize these as the highest priority, and then it will drop off the devices with the lowest priority. So this also makes it a very good, kind of process. So other switches like the 1350 that we mentioned also has this PD auto recovery. Also, this feature is also available in Nebula and under some of the higher end switches as well, as we've introduced that feature. So it's not just beholden to the 1350 series. There are other switches in our series that can also support this solution as well. And I think this is a really nice feature, especially, you can use it for anything, right? It doesn't just need to be CCTV. It could be applied to other applications as well. So let's take a little bit of a roundup on this podcast session and have maybe a top level view of PoE and its benefits.
Yeah, because we've seen some major benefits in lowering cost of installation and removing complexity while giving more control into the network. So it's a really good advantage.
So I think definitely PoE could have some savings in terms of power usage management, especially in buildings or smart buildings. And this also, we now see this e-waste term appearing as well, right? So I think PoE could be a contributor to help you with that as well.
Yeah, and more devices are PoE powered. The obvious things like phones and wireless access points that are most common, but especially applications in IoT or in POS systems, in point of sale systems, are growing markets where PoE power over Ethernet is more required.
Yeah, definitely see more and more like the door panels and the LED strips all coming from this kind of process as well. So I think, again, going back to the power usage, I think this is definitely a pro. And I think final step really is Zyxel has such a massive range of switching, providing PoE, and also of powered devices like access points, 5G products, which are also powered by PoE as well. And I think also one of the things I'd like to really mention is even newer products that we're bringing in. We're introducing a H-series in firewall. And I think this product is quite a clever touch as well, because it also includes PoE and multi-gig on the same port on the firewall itself. So this actually can simplify the installation and remove points of failure in the process as well when we're powering things like 5G routers. So we have the FWA series of 5G routers, and one of the models is actually outdoor. So you could actually have an outdoor 5G router powered directly from the front of the firewall, providing the WAN interface. And I know in the past, even myself, I've installed some of these projects and there's the PoE injector, or I've had to do some VLAN configuration, some complicated configuration on the switch to isolate the port to go back into the WAN, and it gets a bit messy. So I think this will be very much appreciated in the field.
So I think Zyxel has a great portfolio of products that take advantage of this PoE standard. So I think with this podcast, it would give you some more information and background information what PoE is doing and what kind of advantages it has. So, what do you think? Let's go up for the next podcast?
Yeah, I think so. If you're interested, obviously subscribe to our podcast, and there's more information available, and we have a full series of podcasts now that you can relate to. Like I said, there's other topics like multi-gig, and there's some information about wireless and radio as well. And obviously, as we progress, there'll be more and more on these sort of topics as well. So we try to mix up the product launches, the product information, along with some of the technologies. So thank you very much for joining us.
And see you next time.